Hello friends, today we learn the topic about signal reference ground. So in signal reference ground, it is mainly read out as a SIG. So it is signal reference ground, but most of people are speaking out as a single reference ground. Okay, so just take care of this. It is nothing but the signal reference ground. This is the soft copy of the book C. Sankaran of Power Quality Subject, which is covered in semester 8 in electrical engineering department. Further, we have seen the grounding and bonding. In one of that method, it is the signal reference ground. It is short form known as SRG. So this SRG term, how it is useful, we see line to line. The main purpose of the signal reference ground is not person safety or equipment protection, but merely to provide a common reference low impedance plane from which sensitive loads may operate. Here the word important is sensitive loads. Right now we have seen regular loads such as transformers, motors, heavy machinery. Here sensitive loads, we can say it covers the communication equipment, so it is mainly used to transfer the data. Okay, so why it is important of these sensitive loads, let's see further. Suppose we have this one figure we have. It shows the two different micro level circuits sharing with common reference ground. Here ground potential differs due to the excessive ground impedance we have seen in the figure. And through the communication we are transferring say data or signal from one circuit to another circuit. In between these two, this is the resistance, means it is a RG, ground resistance. It is a common reference ground which is grounded through this point. So it shows the two level microcircuit sharing data and power lines. What makes this communication possible is that both devices have a common reference signal, which is the ground. Here the common reference signal is which is the ground. Okay, if the reference ground is a high impedance connection, then the voltage difference may be created that would affect the point of reference for the two devices. Here suppose it has a high impedance, then that might be the possibility that some of the small amount of current will create a voltage drop, so it may create a problem in the communication. So better to lowering the impedance between the reference point of the two circuits, lower the potential for coupling of noise between the device. Here the term important is called as noise. Why so? Because there are noise means any unwanted signal which comes with our data. Okay, why is this so? Because in ideal case, what is happening in ideal case, just what we need, transfer data from one side to another side. Okay, with providing the return path to the ground, but due to the high impedance or somewhat resistance, the return path has a potential drop, so it may affect the return signal. So what we are getting or receiving the data, it may contain some kind of disturbance. So in technical term it is called as a noise. So to avoid that, we need to prefer the reference as a low impedance path. When we mention the low impedance, we mean low impedance at high frequencies. For power frequency, even a few hundred feet of wire can provide a sufficient impedance. But the situation is different at high frequency. See, high frequency, why we are talking about this? Because communication is in terms of megahertz. We know the FM radio, okay? Frequency modulation. So it is has a higher frequency. So consider one example. Suppose a situation when the two devices are connected at 10 feet length of 4 copper conductor ground wire. This is the dimension of 4 gauge copper conductor. The DC resistance of the wire is suppose this, and the inductive reactance at 60 Hz and inductive reactance at 1 megahertz is 20 ohm. Now consider if the noise of current of 100 milliampere at 1 megahertz is to find. And now how to calculate this voltage? V is equal to I into R. So just multiply 100 milliampere with 20 ohm, so it will be 2 volt. Okay, so the noise voltage must be contained of 2 volt, which is enough to cause the device to lose the communication and perhaps even sustain the damage, depending on the device sensitivity. This example is simple situation consisting of only two devices. Okay, so this 2 volt also creates the noise. So if the equipment is more or reactance will be more, then it will be further increase. This example is a simple situation consisting of only two devices. However, hundred and perhaps thousands of such a devices or circuits, thousands of such a devices or circuits may create may be present in actual computer or communication data center. All these devices require a common reference ground which to operate. This is accomplished by the use of SRG. So now actually what the SRG indicates, what our aim is to minimize this noise. How to minimize this noise? Just providing the lower impedance of the reference level, means the ground path. Okay, the main purpose of the SRG is not the electrical safety. See, electrical safety is we already discussed earlier. You can provide it by the earthing or separate grounding, but here the even though the thing we are talking about the sensitive equipments. Okay, so it provides the sensitive equipments. The SRG is a ground plane that provides all the sensitive equipment connected to it a reference point from which to operate without being unduly affected by the noise. Okay, that may be propagated through the SRG based device, external or internal to space protected by the SRG. That means what? The noise may be present. The noise may be present in the SRG, but presence of the noise should not result in a voltage differential or current loops of level that could interface with the operation of the device that use the SRG for the reference. What it indicates actually. See, the benefit of the keeping the SRG as a low impedance level is that it will contain the noise within itself and it will not transfer it to the communication devices, means sending end or receiving end. Okay, so the noise is within this that loop only. It is not a SRG is not a standalone quantity. Okay, for a safer side we can say that we can also, it must be bonded to the other building. It must be bonded to the other building ground electrodes such as building steel ground ring or concrete encased electrodes. This requirement permits any noise impinging on the SRG to be safely conducted away from the SRG to building steel and the rest of the ground ring system. That means what whatever is the SRG we have created, that must be connected to the another main building steel or ground ring or concrete steel, so that that potential may be go into the ground easily. Okay, so this is the main concept of the single reference ground. Now we have already seen this figure. Now just go further, the single reference ground method, how we can connect how we can make this SRG. Normally it is nothing but a simple method. So what generally we are doing, the single conductor installed underneath the floor and looped around the space of the computer center. Suppose we have computer center, so one conductor is buried underground the floor and hold the computer areas, means connected to that conductor through the loop wires. But the one problem is that as the length of this conductor increases, the impedance is increases, because R is nothing but rho L by A, rho L by A. So just consider this rho L by A equation. So as the length increases, the resistance will increase. So again there will be a problem of noise in the sensitive equipment. Here more detailed example is given here. The two AWG means American wire gauge. Okay, the SRG consists of two American wire gauge copper conductor. So here copper conductor, it creates, just wait a minute. Yes, here are the two large copper conductor underneath the floor of the communication center from a gate. Distance is 2 by 2 feet. So this is distributed in 2 by 2 feet square. So as per we can see that it is creating a one kind of mesh, means 2 by 2 feet single reference signal reference ground arrangement. Here is the, this point indicates the crossover welded together or bolted together. So let's see what is happening in this. A preferred SRG consists of two large conductor laid underground. By creating the multiple parallel path, the impedance for the reference plane is made equal for all devices. See, here the parallel paths are multiple. So what we are doing, just we need to keep the impedance for same for all the parallel paths. So for that, what we are doing here, we are just connecting. We are just keeping the parallel path same for all the equipment. So SR here single we can say that the multiple parallel by creating multiple parallel path, the impedance for the reference plane is made equal for all devices and circuits sharing the SRG. If the impedance is measured at any two nodes of the SRG and plotted against the frequency, the shape of the frequency characteristics would appear as shown in figure. Okay, why we are plotting this graph? Because see, this area is very much large. Okay, so we need to give the same impedance path for all the equipment, sensitive equipment connected to this signal reference ground. So as per the graph, across the any two nodes of this circuit, this graph must be remain same. This graph must be remain same. So here, the impedance versus frequency graph should appear the same across the two sets of node of the SRG, as this is the main objective of the SRG. So there should be no any impedance differs between any devices to the ground. Some of the buildings may prefer the copper strips instead of the circular conductors to form the grid. Other facilities might use the sheets of the copper under the floor of the computer. So the arrangement may vary according to our requirement. Constructing the SRG with a continuous sheet of copper creates a reference plane made up of infinite parallel paths instead of a discrete number of parallel paths as with the SRG made up of a circular wire. Here, what is saying that what they are saying, constructing the SRG with a continuous sheet of copper creates a reference plane made up of an infinite parallel path instead of a decreased number of parallel path with the SRG is made up of a circular wire. So circular it is better. So what differs in this continuous sheet? Here the sheet means the across whole the area covers, ground area covers, so it creates a lots of parallel path instead of the proper particular fixed number of parallel path. The SRG is also bonded to the building steel and the sections that supports the raised floor of the computer center. So the what the SRG this raised center indicates here, just see this figure. This is the computer rack. Okay, this is the floor, this is the building steel, this is the building steel. Okay, so this figure indicates the area of all the arrangement. See this is the whole mesh what we have seen earlier. This is the raised support for snatches. Okay, this is the various connections from SRG to the ground, finishing to the ground. Okay, so all the areas are connected. SRG to the building scenes, these are to the other SRG ground level, these are the common reference means signal ground bus, and this is the ground grid systems. So what it says, the SRG is also bonded to the building steel and the stanchions that support the raised floor of the computer center. Such an arrangement provides excellent noise immunity and allows the creation of a good reference plane for sensitive circuit. This arrangement provides the good excellent noise immunity. Here the noise immunity and allows the good reference plane for sensitive circuit. Despite of this, SRG for large size computer center might be configured. Okay, so these type of methods are used. And also the one take care we should take care about this. It is important that all noise producing the loads kept away from the SRG. All the nodes kept away from the SRG. If such a loads are present, they should be located at outer periphery of the data center and bonded to the building steel. Okay, outer periphery and bonded to the building steel. Here the bonded to the building steel. So it can easily create the low impedance path, because steel is also has a separate copper wire through it is connected to the ground. Okay, so in this way, what we can understand from this, the signal reference ground methods, how we can do that that signal reference ground method, and what is the importance of that, and how it is useful in sensitive equipment. Thank you very much.